Welcome to The Explainer. Today, we're going to get to the bottom of something that feels a little bit like magic. How is it that one single piece of code can run on your Windows laptop, your phone, and maybe even your smart fridge? Well, the answer is all in the super clever design of one of the world's most popular programming languages, Java. So, this is the big question, right? It's the famous write once, run anywhere promise that really put Java on the map. But how does that actually work? It sounds impossible. Stick with me because in this explainer, we're going to pull back the curtain and see the ingenious trick that makes it all possible.
So, here's our game plan. We're going to start with the absolute basics, the building blocks. Then we'll see how data gets stored and assigned. We'll take a quick detour into different number systems, and then we'll get to the grand finale, Java's platform trick.
Okay, so first things first. What is a Java program even made of? If we could zoom all the way in, what are the smallest, most fundamental pieces we'd actually find?
Well, just like a sentence you'd read is made up of words and spaces and punctuation, a line of Java code is made up of things called tokens. These are the absolute smallest, meaningful units that the computer can actually understand.
And here they are. What's kind of mind-blowing is that every single Java program you've ever seen is built from just these 5 types of tokens. That's it. You've got identifiers, which are just names for stuff, keywords, which are special reserved words, operators for doing things like math, delimiters to give it structure, and literals, which are the actual raw values. It's the entire Lego set.
Okay, so now that we know what the pieces are, let's see how Java uses some of those tokens to actually remember information.
So, an identifier is basically just a label you make up. Think of it like putting a sticky note on a box. It's a friendly name that points to a specific spot in the computer's memory, so we can just say, hey, what's in score, instead of trying to remember some crazy long memory address.
Now, this is really important. Java is what we call a statically typed language. What that means is you can't just create a label. You have to tell Java exactly what kind of data is going to go in that box. Is it a number, a single letter, a true or false value? It might seem a little strict, but it's actually an amazing feature that helps us catch a ton of potential mistakes before our program even runs. When it comes to data types, they pretty much fall into 2 camps. On one side, you have primitive types. Think of these like individual Lego bricks. They're the most basic, indivisible things, like the number 5 or the letter A. Then on the other side, you have non-primitive types, which are like the cool structures you build with those Lego bricks. A great example is a string of text, which is really just a bunch of individual character bricks put together in a row. And here are the 8 main primitive types in Java. This table's a great little cheat sheet. What's cool to see here is the range of sizes. You have a Boolean, which is just a single tiny bit for true or false, and then you can go all the way up to a long or a double, which use 8 bytes to store really, really big numbers. Having this level of control is a big part of Java's design.
All right, so we have our storage boxes, we've put labels on them. Now let's actually put some stuff inside.
This one simple line of code shows us everything. We've got int, which is the keyword telling us the data type, it's an integer. Then, my number, that's our identifier, our label. The equal sign is the assignment operator. And 42 is the actual value we're putting in the box. And this whole act is called initialization. That number, 42, actually has its own special name. It's a literal. A literal is just any fixed value that you type directly into your code. It's not a variable, it's not a box, it's the raw data itself. It's the actual number, the actual piece of text. So, we've talked about storing numbers, but, we humans think in our normal base 10 system. Computers, though, deep down, they just think in ones and zeros. Java actually gives us a really neat way to speak their language.
And this is super useful for certain kinds of programming, especially when you're working closer to the hardware, or dealing with things like network protocols or even color codes.
Java makes this really easy. It just uses a simple prefix system so it knows what you're talking about. If a number starts with 0b, Java knows it's a binary value. If it starts with 0x, it knows it's hexadecimal. This little prefix is all it takes to tell the compiler exactly how to read the number that comes after it.
All right, we have covered all the basic building blocks. Now it's time to connect everything back to our big original question. How does Java pull off its run anywhere magic? Well, the secret is in a brilliant 2-step process.
See, most programming languages use one of 2 ways to translate code. A compiler takes the whole program and translates it all at once into a fast machine-specific file. An interpreter, on the other hand, translates and runs the code on the fly, one line at a time. But Java, Java does something really clever. It uses both. It's a hybrid.
So here's how it goes. First, the Java compiler takes your human-readable code, and it translates it. But, and this is the most important part, it doesn't create machine code for a specific computer. Instead, it creates this intermediate language called bytecode. And this is the secret weapon, the Java Virtual Machine, or JVM. You can think of it like a little virtual computer that lives inside your real computer. There's a JVM built specifically for Windows, another for Mac, another for Linux, and their only job in the world is to understand that one universal bytecode.
So here's the magic trick laid bare. You write your code just one time, you compile it just one time, creating one universal bytecode file. And then the specific JVM on each computer takes care of that final translation step, turning the bytecode into instructions that the local machine can actually run. Write once, run anywhere. It's brilliant.
So let's wrap it all up. We saw how all Java code is made from just 5 simple types of tokens. We use those to create identifiers and data types to hold our information. And most importantly, we uncovered the secret to Java's platform independence, that amazing 2-step process of compiling to universal bytecode, which is then interpreted by a platform-specific JVM.
And that leaves us with a really interesting thought for today. In a world of cloud computing, containers, and web apps, what does platform independence even mean anymore? Has the problem that Java solved just changed its shape? Or has its solution actually become more important than ever? Thanks for joining this explainer.